voice user interfaces and introduction of lab automation in research and education. Well, in general, not in the smartlab network, but in my experience, the general knowledge about lab automation is unfortunately rather limited, still rather limited, even when you talk about the group of researchers in the bioscientific field. And one scenario which I have now witnessed so often that I'm eager to call it standard scenario is the following. In many companies, many departments, a very usual situation is that in the end of the year, money still has to be spent. I think most of you know this situation. And then is invested into standalone lab automation equipment, like, for instance, a liquid handling system. But this only happens in one single department. And then, of course, this department receives the equipment, receives certain training for this piece of equipment. But also in the end, it's always the same, not always, but most of the time, fundamental considerations which would have been taken into account were not taken into account. So, for instance, regarding the networking of processes, let's assume that this liquid handling system is placed in an analytical department, but suddenly the analytical department has to wait for 3 or 4 weeks until there are simply enough samples that it's worth starting this machine. Or in terms of logistics for automation, a common problem is that now you realize that, oh wow, I need a lot of antibody and that's actually not available. So pretty simple and unfortunate things which were not taken into account when this money had been spent. And this all leads to the fact that those lab automation devices are not or hardly used. And even more unfortunate, in some of those departments, people come to the conclusion that lab automation is not for us. And that's, of course, a big problem and a pity. Where do I see the reasons for these knowledge gaps? Well, the reasons start pretty early, in my opinion. Whatever discipline in the bioscientific field you look at, whether it is biotechnology, biochemistry, molecular biology, and so on, the training, the study courses, and the fields in themselves are pretty complex. And looking at study plans during those degree programs, bachelor and master, they actually leave pretty little room for lab automation. Because as I said, those fields by themselves are so complex that you need to include a lot of basics already. As we all know, biologists, chemists, and other life scientists, well, they are usually not engineers, nor are they computer scientists. And lab automation sounds a bit funny, but is still, in my opinion, a relatively unknown new discipline in many research areas. And I say funny because it's really amusing when you look at articles like this here. 13 years ago, the first 110 years of lab automation. Well, I think we can agree it's not exactly a new discipline, but when you look at some areas of research or fields like clinical chemistry, of course, lab automation has been common for many, many decades, no doubt. But there are still many research labs in which basically nothing is being automated. In the end, we also have to admit, I think, that the user-friendliness of most lab automation devices could still be improved, to say it mildly. If you then talk to researchers which are not that familiar about lab automation, what are the benefits of lab automation? The usual answer is it's all about high throughput. And they might not know the 1536 format, but maybe the 384 well plate, and of course everybody knows the 96 well plates. But nobody hardly thinks about the quality improvements lab automation, of course, offers. And with that little bit of introduction, I would already like to come back to one of those introductory slides. These fundamental considerations, which in many departments, in many companies do not take place when purchasing now new lab automation equipment. In our research group, we thought about a question: how can we prevent this from happening? Can we do something to improve the situation? And the idea we came up with was to write a feature article, which was published in Analytical and Bioanalytical Chemistry last year. You can see the title: Can I Benefit from Lab Automation, a Decision Aid for the Successful Introduction of Lab Automation? So basically the idea to provide some kind of, I don't want to call it guideline, because we all think of other things when we hear about guidelines, but yeah, the term decision aid already describes it pretty well, I would say. In this feature article, we went a relatively uncommon way to write the article. Of course, it has a couple of pages, I don't know, 10, 11, 12 pages or so. But of course, for everybody reading this article, the situation is already different from the beginning. You might know little or a little bit more about lab automation, and goals differ, of course, when you want to automate a certain process. So the way we wrote this article was inspired by adventure books, which were popular maybe in the 80s or 90s. Here, Choose Your Adventure Heroes and Monsters. So what's the principle of those adventure books? I think not everybody's familiar with it. You read those books, and you as an adventurer, you come maybe to a crossroad and you have to decide, am I going left or right? And if you go left, you continue reading on page 21. If you go right, you continue reading on page 25. And in the end, maybe you survive or you don't. But that's basically the idea of those adventure books. And now we wrote our own adventure: Can I Benefit from Lab Automation? And that's how we structured this article. It was actually pretty interesting to write, because you had to go back and forth so many times to see if it makes sense. What we provide in this article is basically a step-by-step guide, which everybody can follow with her or his own goals, of course, what kind of process is to be automated. And then after reading introduction and theory, you go through all those processes. You have some rethinking processes, of course, after you have acquired the knowledge of the article. And later on, we also provide some kind of decision trees, which I'm going to show you some examples of later. And in the end, the decision either is, and that's what I want to start with, it's actually not recommended to automate the process. That can very well be the conclusion. Of course, it can also simply be to purchase a certain system which is suitable for the process, revive an unused system, or other decisions, whatever process you have in mind. Here I want to automate an ELISA or other things. I certainly don't want to go through those decision trees, just to show you how those decision trees are structured here, with a big question: is my planned throughput suitable for the automated system I am looking at? And then you go through those different questions and answers here, and in the end it's recommended to read a certain chapter 9, 10, 11, or go to a certain decision tree. As I said, there are several decision trees. What we also provide in this feature article is a scoring checklist. It might be the situation that you have several processes which could be suitable for automation, and here we provide an opportunity for everybody to judge what might be the best one to automate, and what may be the worst one to automate. Yeah, I'm curious to receive more feedback over the years, how this works or how this doesn't, but at least in our opportunity, this could be a possible answer for everyone. This article is free to download, and in the end, as I said, there are several decisions which stand at the end of these decision trees, and reading the articles, and of course several facts are being taken into account. So with that, let me go back already to another introductory slide I have shown you, and that's ended with the user-friendliness of most lab automation devices, which in my opinion should be improved. You all know these kind of graphical user interfaces of whatever lab automation device you might think of. And these graphical user interfaces, well, it often reminds me to this here: a user interface is like a joke. If you have to explain it, it's not that good. And I think you all have examples in your mind where this is actually and unfortunately the case. When thinking of lab automation devices, more complicated systems with user instructions of 1,000 pages of a PDF in one single language, well, this can be improved. And ideally, a lab automation strategy, I think we can all agree, would not need any explanation whatsoever. Where could this be the case? And if you think of your smartphone you carry around all the time, it works pretty well in a smartphone. And I had the idea when using my smartphone that a voice user interface could certainly be helpful in the lab. And whenever I used my smartphone and talked to it, well, I think we had some communication problems. The language I was using in terms of scientific language was hardly understood to a level where I was satisfied. And that's why I thought it would be nice to create a voice user interface for the lab which is capable of understanding very specific vocabulary. And that's why we have created a voice user interface which we have called Rainbow, which uses a very common voice user interface, Google Translate. And Google Translate is able to convert speech to text, and of course also the other way around, text to speech. But the problem is that whenever you're using a specific language, like maybe SDS page or Western blot, this is of course not vocabulary which is commonly used, and maybe you say SDS page and Google Translate understands this page. Yeah, could happen very well. The idea we had was, well, it works pretty well, but let's try to improve it. And how can we improve it, and what should be the goal behind it? And when we thought about it, we thought the goal is that actually every user should be able to train the system with specific vocabulary which is used only in one single department, or maybe even only in one single kind of laboratory. A stem cell laboratory uses different vocabulary than a biotechnology laboratory. Why aren't we able to specifically adapt this voice user interface to the needs of a certain user of a certain lab? And of course, we have another problem in voice user interfaces, also in international lab environments. Well, if we are talking about Germany, we have different dialects already, like the Saxonian, the Swabian dialect, and so on. The pronunciation is, of course, always different, and that also leads to misrecognitions in the voice user interfaces you're using. So, what have we done? As I said, we used Google Translate as a basic voice user interface and then combined it with a locally installed Windows automation software, AutoIt, and a graphical user interface, simple to use, in which every user can type in specific languages and can correct Google Translate locally on the computer you're using. So for instance, if you are always saying SDS page in your laboratory and Google Translates, let's stick to example, always recognizes this page, you would type in what the misrecognized vocabulary is and correct it. I'm going to show you the results in a moment, but what have we done with this voice user interface? We constructed it in a way that you can use basic Microsoft Windows skills, that you can use some relatively basic laboratory skills I'm going to show you in a second, and also for using certain analytical instruments. When you use Rainbow, you actually do so by saying rainbow, the word rainbow, and then the voice user interface answers task menu, say command after beep, and then you say the command, the vocabulary you have trained the system with. Then the system is, the task is executed. What kind of basic functions have we trained the system with? Level 1, level 2, and level 3 functions. When you look at the Windows, Microsoft Windows skills, this is something like open a file, execute a certain program, which starts a program, display my desktop, hide all windows, print, maximize, minimize, show, save, and so on, copy, cut, and so on. Something which I have called laboratory skills on the slide before. We have included a timer, so that you can simply say set timer, and then the system asks you, okay, how many minutes or seconds, and you simply do so and start the timer. We have included some calculation tools, for instance, for dilution series and so on. Note taking and a narrate protocol function, amongst other things. So what can Rainbow do? First of all, and that's what we've started with, it's frustrating if a voice user interface doesn't understand what you want. And that's what we were able to improve quite drastically. Google Translate alone, the average number of errors per 100 commands given was around 15. So 15 commands were wrong per 100 words, and that's a catastrophe. It's not fun to work with. Now, a Rainbow which was trained for some very general mistakes that would be in a more bioscientific bioscientific lab, reduced this number of errors approximately by 50%. Then we asked some users to train the system further and to eliminate the most common errors, and that didn't take long. And we were able to improve it to about 1 to 2 errors per 100 commands given. So it worked out pretty well. There is a video now provided also in the publication. I'm going to show you. I don't know if it's possible for you to understand everything. Of course, the idea is you are wearing a headset and communicate with the voice user interface while, of course, working in the laboratory.
Please set your timer. Say number of minutes of the work.
That was the timer functions. The plate carrier here opens as a result of a command given by the voice user interface, and closes, of course, some different functions. All of it is described here in this publication. The whole system is open source and available for download at nature.com in scientific reports published in 2023. Now, last topic for my talk today. Again, I'm coming back to an introductory slide. Reasons for the knowledge gaps I've mentioned in lab automation. I said something like study plans during degree programs in the bioscientific disciplines, they usually leave little room for lab automation. And I also said that biologists, chemists are usually not engineers or computer scientists. What are we doing at Albstadt-Sigmaringen University to train the next generation of scientists also in lab automation? Both in our bachelor degree program Bioanalytic, also part of the master degree program Biomedical Sciences, we include courses in lab automation. And in Bioanalytic, in our bachelor degree program, this takes place in study years 2, 3, and 4. And we include a minimum of 200 hours in lab automation. And then this can be voluntarily extended to 1 year if you include, for instance, bachelor thesis, practical years, and practical semester, and so on. During those 200 hours we include in the training, study objectives for the students are that, of course, they should know the advantages and disadvantages of laboratory automation in general. They should be capable to find the right lab automation strategy for a desired process. We hope that they know the important theoretical principles and also the concepts in lab automation. They should have pretty extensive insights in the various lab automation solutions out there on the market. They also definitely have some practical experience that takes place in study year 4 with robotic arms and different liquid handling systems. And they obtain programming skills in Python and another programming language at beginner's level, whereas I define beginner's level with this definition here with 5 different levels. Advanced beginner, the next step would already be a bachelor in computer science. So that's why I'm saying beginner's level. And they can independently automate Windows controlled processes to start lab automation on a low level and with little equipment. So all in all, the aim is to create bioscientists with a deep level of knowledge in applied lab automation. And applied lab automation certainly does not mean that we want to turn bioscientists into engineers or computer scientists, because that simply wouldn't work out, in my opinion, and would pretty much result in a catastrophe, I would say. So we really are not aiming for a deeper understanding of the underlying hard or software, simply because that is something we cannot combine in these, as I said, complex bioscientific fields. One last word to where we are located. Albstadt-Sigmaringen University is located close to Lake Constance, here in the middle of nowhere. That's a pretty good place to keep it a secret. No, just kidding. It's a small university. We have roughly 3,000 students, and so it's a big deal if, like very recently, Albstadt-Sigmaringen University is mentioned in the news. Most popular Hochschule university. So in this Study Check Award, very recently we were ranked 1 out of 588 participating universities. In terms of digital readiness, number 2 out of 588, with the IU, the International University, a distance learning university with 130,000 students, being number 1. And for bioanalytic in the CHE ranking, Germany's biggest Hochschule ranking, university ranking, 1 out of 174 in 2022. This goes to the next round this year. I'm pretty curious where we'll end up. But as you might have the impression, not the worst place to work and study. With that, briefly coming back to the topics today, the guide how to introduce lab automation devices to a laboratory, Rainbow, the voice user interface, and last but not least, training the next generation of scientists. I would like to thank my co-workers, Nicole and Rebecca. You're also here and can maybe answer some questions better than me in the end. And of course, our collaborators from industry. And of course, in the end, also you for your interest and participation today. Thank you.